Hey, welcome back. So we're going to talk a little bit about the amperage setting and the voltage setting on a JK BMS. When you get them, a lot of the times they're not very accurate, or they're somewhat accurate and you just want to fine tune them. There's a couple of tricks to doing so. So in the first section, I'll go over how you go through and determine what the voltage is, get that set, and how you set it in the app. And it is significantly important in that it is what controls. You may use it for controlling other devices of when they're supposed to be charging, when the cutoff is, what the float rates are, those type of things. So it's really important that that's as close or as accurate as it possibly can be. Otherwise, what you'll find is that this battery continues to take a charge well beyond or cuts off earlier than other batteries because the float rate or because the charge rate may be wrong. I'm sure there's other side effects. So those are the only couple that I can just think of off the top of my head, and that would mean that obviously if you've got it set to 54 volts and it's actually at 56, then it would be really almost fully charged when it actually saturates at 54, which is technically 56. So it's important that 56 volts is actually 56 and 54 is 54, and that way all of your batteries saturate at the same thing. This is anytime you're using batteries with voltage, that's going to be a thing that you're going to want to deal with, is making sure that voltage is adjusted between all of them so that they all charge the same way, they all discharge the same way. And a lot of the times the way I've looked at this is look at cell voltages across batteries. Now, it isn't going to hold true at past the knees, but in the middle of when you're at 50%, most of the cells will be around the same voltage, even across batteries, as long as all the batteries are at 50%. So that's something that you kind of really want to watch and kind of keep an idea at least that's what I've been doing to make sure that I get my batteries in sync. The second part that we're going to deal with is going to be the amperage. Now, this has the largest impact on that state of charge reading that you see on there. And if you're running closed loop, then that state of charge becomes pretty important. If you're not running closed loop and you're running based on voltage, then the only one that's really important is the voltage, and that you can ignore. In my case, I have a screen on my JK, and I don't have a screen on my EG4. So I only see the EG4 that gets reported through Solar Assistant, but I do see the screen on my JK, and I like to see it also going through Home Assistant. So I like for it to be accurate so that I can compare the two and see if there's something drastically wrong with the different percentages across the batteries. A lot of the times these are difficult to set and to get exactly accurate because the devices that we use to measure them isn't super accurate. At least in my case, it's not. If you've got some really nice equipment that you can get very consistent readings, and you'll see that when we start looking at how you adjust these. If you can get very consistent pulls from a battery at exactly certain watt amperage, and then you can adjust it based on that. But some of these are a little bit tricky. So I'll give you an example of how much of a difference this can make. If you go in and set your BMS based on 20 amp pull, and you were off 1/10 of an amp, that could register down to 0.5% inaccuracy in the state of charge calculation over time. And over time, that inaccuracy will add up considerably and make for a very, very big difference in the slip of what your state of charge accuracy is reporting. In my case right now, I'm off a little bit, and my Victron shunt will report that my battery, let's say it reports 80%, but my JK BMS may report 83 or 85%, depending on how long it's been since I've done a resynchronization. So the idea here is to get them as close to possible and to narrow this gap as much as you can so that it stays accurate as long as possible. So when you're adjusting it, it's important to adjust it at a rate that is as high as you can possibly get it. So for example, at 20 amps, if you're off by 1/10 of an amp, then you're off a 0.5%. But if you do the same setting of that amperage at 80 amps and you're off that same 1/10 of an amp, now you're only off 1 1/4 tenth of an amp. And therefore your drift on your state of charge will be a lot less than it would have been if you'd have set it at 20. Not all of us have the ability to set things, so you have to do what works best for you. I found that once you get it close enough, it's close enough, and you play with it for a little while until you go in and learn what you've done a little bit and try it again. So it may be a matter of, especially at first, the shunt is very inaccurate when you first get it without your first adjustment. So go in and do your first adjustment, live with it for a few days or a week or 2 weeks, and then go in and do a second one if you need to. But it's important to do both of these. Set your voltages up. I suggest you set the voltages up first because voltage is used to calculate amps, and then set your amperage up afterwards. I don't know if the two are connected in the battery or if one affects the other calculation. And no, it does when I'm doing math and on a piece of paper and saying how many amps do I have versus voltage, but I don't know how the battery is doing that. Is it actually using the actual true battery voltage, or is it using the voltage that's reported on the screen that we see? So these are questions that there's no way for us to answer without being part of JK and the programmers that develop the BMS. So I will walk you through first how to set the voltage, and then I've got a second section on how to set the amperage. I set it to a fairly low amperage, but I've also got a pretty good accurate BMS already. And so when you do that, even at 20 amps, you can get pretty close to what you want. The drift still becomes pretty bad over a period of 2 weeks, which is why I'm doing it again. And you'll note that you'll see that I'm still off a little bit, and that I've tried to do my best to fix that. So we'll talk to you later. Enjoy the rest of the video. Please make sure you subscribe and like the video so that I continue to make more. And I appreciate everything that you do, and I hope to see you again next time. All right, in this section of the video, I've taken you out to the actual battery bank, and I'll just pull this back and kind of show you what I've got here. So the battery is here, and I've got this protective PVC on top of it to keep the cells and everything safe. But as you can see, there's the inverter and everything is also out here. But what we're focusing on today is this new battery bank. This particular section of the video is about specifically looking at the voltage of the battery bank that's coming in and being able to adjust it. Now, in another section of this, we will play with the amperage and get it correct. But in order for the amps to be correct, we need to make sure that the voltage is correct first. So what I'm going to do is I'm going to walk you through the steps that I'm going to take to do this, and hopefully get this at a spot where you can see it and I can actually still do what I need to do. Put this on DC, put that light on so you can actually see it. It looks like that works pretty well. Okay, so here I have the shut off for the other bank, the rest of the battery bank, and I've got this turned down to 4 amps, or excuse me, 10 amps right now coming in from the charger. So what I'm going to do is I'm going to take care of setting the voltage here first. But before I do that, what I want to do is I'm going to disconnect all the other batteries, and I want to let it just sit. So I'm going to turn down the charging voltage so that when I shut this off, I'm not shutting off a whole bunch of current flowing through. And I know it's only 10 amps, but it's when it's not necessary, it's not necessary. So first I'm going to go over here to, I'll show you on my solar assistant. I'm going to go into my solar assistant here, and I'm going to just run over here to the settings, drop down here to the battery, and change this down to 1 amp. And we'll let that update. And I will pull over, can't pull that over, so I'll have to pull the camera back so we can watch that drop on the meter here. So it takes a few minutes for it to register the new voltage and for it to drop, or the new charging voltage, and let it drop. It looks like there it's starting to move. It looked like it was going to start to move, and it'll happen all of a sudden. It's pretty dramatic when it does happen. It looks like it did not take the setting I'm going to ask for it again over here with the solar assistant. Sometimes it does this. I'm not sure if that's a MQ issue or... Alright, so we sent it again. And then we're going to watch back for the amperage here. I want to get this as close to 0 as possible so that, you know, when I flip that switch, I'm just shutting the battery, not cutting off a whole bunch of current flowing through. And then what we'll do is we will, after this is done and we get the voltage set, in the next piece of it, what we'll do is we will then cut the, this is the only battery, put the charger way up to 80, 90, 800 amps or so, and then we will be able to adjust the amperage based on what we're seeing there. Is this thing ever going to take effect? Looks like it's really having problems with it. I'm going to go back again to the main screen, make sure I'm still connected. I've noticed sometimes when it gets disconnected it doesn't work. And then I'm going to scroll back down here to edit and change this. Maybe it's just getting rejected because it doesn't like 1 amp. Let's just try 5 amps and see if that works better. Sometimes it has a problem with low settings because they figure it's not enough for them to mess with. And look at that. 1 amp finally took a count. So that's probably just solar coming in then. So what I will do is I will just go ahead and I'm going to quickly click off my Victron charger so I can lose some of that excess solar and see if I can get it down just a little bit lower. The Victron is basically some extra panels that I have set up on a shed. It looks like that's not going to be enough either. So either way, at this point, that's enough. We're just going to go ahead and flip this battery off. And as you can see, that definitely took care of it. I lost it. Where did it go? Oh, there it is. All right, so I shut the battery off. And now we are sitting at 0 amps. And we are showing 53.49 volts. So what we're going to do is we're going to take the voltmeter, which I'm using this Klein voltmeter here with 4 decimal points, and I'm going to get here to the negative bus bar and the positive bus bar, or the negative and the positive post. Now, negative post is right down in this area, and the positive post is right here. So it's showing 53.4 on this. So what I'm going to do is I'm going to pull open the app, the BMS app, and I'm going to put this down here where you can see it also. 54 point. Looks like I've adjusted this once before, so it looks like this might be pretty close. You can see, hopefully you can see both of those clearly, and you can see me putting the probes down here on the battery. So we're going to go back to putting the probes on the battery. If I can find that darn negative post. Eyesight's not as good as it used to be. Come on now. There we go. All right, 53.4, and we've got 53.46. So that's pretty darn close. I think we have the voltage set. I don't think I'm going to change that again. I did set it once before. It was off by about a half a volt when I set it the first time. So I thought it was good to set it again. But when I did it the first time, I set it based on it being active and operating. And this time it is truly not, has 0 amps coming in and out. So I thought it would probably be good to check it. And it looks like that's pretty darn accurate. It looks like it's a half a... Yeah, I don't know that this thing is going to register enough decimal points for me to see it. I thought it was 4 decimal points, but Looks like it might not be. Alright, so with that being set, and everything there being pretty good, if I had registered, let's say it's 53.4 and I want to change it, then the way to change it is to go into the app and put in your password. And then right here, right here at 53.4, this is where you would put in the actual current voltage. So what we could do is we could put this on here and say it's 53.4, and we'll just change this to 53.4, hit OK. Now when we show this, they should be the same, and that will make, there we go, that will make everything with the amperage more accurate, as it is hovering right at the correct voltage on that one. Now amperage is next. It's a little bit more complicated. I'm going to turn this battery back on. We've got a little bit of an inrush at 20 amps there. It should drop quickly. We're just going to watch this voltage for a little bit longer, make sure it stays accurate. It's 53.5, which it is, and it should drop off a little bit as that amperage balances back out. And then once this all levels back out and everything's back to normal, what I will do is I will come back and start another recording with the measuring the amperage, and we will do a couple of different measurements there to see how accurate we can get that. But at this point, this thing is resynchronizing with the other battery, so we're just going to let it run, and we will see you here in a short bit. Alright, so we're here to adjust the amps on the battery this time around. This is the part that has the most impact on that percentage that you see there. And I know mine's off a little bit because my battery voltage returns higher than the Victron shunt, which is right buried back there. I can barely see it. There it is. So the idea is to take this battery and adjust. We already did in the previous section. We did the voltage. So now we're going to adjust the amperage so that this matches what is actually happening with the battery. So we've got an amp meter here. Questionably, it's going to be hopefully more accurate. So here's what we're going to do. We're going to switch this over here to volts. I know I happen to be under 40, so I'm going to use under 40. And then we're going to change it to DC. And I'm going to turn the light on, or zero it. And then I'm going to put this meter right here on this battery cable so we can see what the amps are. And then I'm going to open up on this one, I'm going to open up the app so that we can see how to set it. And then over here, maybe I can bring this down here where we can see all of them in the same screen. Maybe not. Let's try it this way. There we go. So now we can see the amp rating coming in versus what is actually being shown. I'm just going to move this app out of the way. Put this right there. See if we can get all of these. I probably should have arranged this before I went through this, but that's okay. You do get the point. So here we can adjust in the app what the current amp reading is. And you just edit it to what it actually is showing, and that will change it on the screen here, and also determine the rate of intake and burn down on your thing. Obviously, the more accurate you can get with that reading, the better off you are. Now, they suggest you do it with as highest amp rating as you can get. I'm going to do it here. It's still, I only have 18 amps running into the battery. I should probably do it with more than that, but I'm not going to. I just want to demonstrate exactly how it's done, and then you can do that with your own. So, here we go. We are going to figure out where that shadow is coming from so that I can move it out of the way. There we go. And that didn't help much, did it? And maybe if I push it up here. All right, so we are showing 18.5, and we are only showing 18.2 or 18.0 over there. So the idea is to adjust the rate that shows up on the battery to what it actually is. So right now it's 18.4. So what I'm going to do is I'm going to switch over here to the app. And we have it open already. And we are going to match this as closely as we can and see if we can get a consistent number here. So what I'm going to do is I'm going to change it to 18.4, which I can't do. All I can do is whole numbers. So what I'm going to do is I'm going to change it to 18, and then I'm just going to wait for this to actually dip down to 18, and then I'm going to hit save when it does that, and hopefully that will get it more accurate than it is now. As you can see up there on the top, it's showing 18 right now, and it's actually 18.4, which would account for the difference that I'm seeing. And the burn off, I'm only showing 18 amps burning when actually 18.2 or 18.4 is burning. So there we go. We show a drop there. It's going to stick here at 18.7. So what I'm going to try to do is go turn off one of the other batteries and see if I can get this to be more consistent. Alright, real quick while we're here, I just flipped off another battery, and as you can see here, we're showing 22.3 and 22 on that. So what I'm going to do is I'm going to update the app to say 22 as it's been dipping down. And I'm going to set it right here. And we are just going to watch this for a few seconds and see if we can get it to dip down like it is now. Oh, almost. It's just not quite going to participate today. Well, the good news is eventually we did get the adjustment done. I don't know what happened to the recording. I was in here constructing the video and putting it together, kind of show you. I turned off all three of my other EG4 batteries and got it up into the 40 amp range and did a pretty good adjustment. So although the process isn't any different than what you saw, you basically run the amperage as high as you can get it as close to a whole amp as you can get, and then hit the set button on the app to make sure that it's there. Monitor it to make sure that it comes in as close as you can get it there, and then test it out over a period of time to make sure that it's accurate. That's the best thing that you can do. I'm sure there are cases where even what it's recording doesn't come in as accurate as what it's as it could be. So you may have to do it multiple times to get it right. It's a very flawed process, but I'm not sure, other than having a couple of bench testing ways to pull a certain amount of voltage out of a battery and then be able to set it based on that. Where if you could pull, a good consistent 40, 50, 60, 100 amps out of it and set it to a precision value like that, where you knew it was exactly 100 amps and you were setting it that way, that would probably be the best way to do it. I'm not sure exactly how the Victron shunt is so accurate in its settings, and the BMSs can't seem to get it close to right. I think something to do with the way the connections are made with the batteries and all of that kind of stuff. But I'd love to hear from somebody if they understand exactly why the Victron shunt can be adjusted at the factory, and when you get it, it can be very, very close to 100% accurate. And when you have the same thing going on with all of these BMSs inside these batteries, they just can't seem to get it right. Amazingly, they have the entire battery all put together when it leaves the factory, so they should be able to adjust the accuracy. It may be cheap components and they just don't have, the funds to put that type of a shunt in the battery. That could be the answer. But it does seem a little suspicious that you can't get it anywhere near as accurate unless you use one of those really expensive shunts, which I have one. I like it. But at the same time, I like my batteries to report the right thing. Anyway, I appreciate you watching. I hope you've hit the subscribe button by now. If not, you've stuck with it this long. This is the kind of content I do all the time, so go ahead and hit that subscribe button, and you'll see some up-and-coming videos and things going on with the solar shed and things going on with the batteries and the capacitor charging switch that I built coming up in the next video or two. So we'll see you then. I appreciate you. Have a good day, and talk to you next time. Bye.